The saga of tattoo wheels. This is printed centres on salvage tyres. That's a tyre, and it's taken from a plastic sintered coach wheel. And I've printed, and you can't quite see, yeah, I've printed centres. Now, part and parcel of this was a means of gripping the wheel, and I printed on the FDM printer this, call it what you like, a split collet, a step chuck, or what have you, and this goes into my collet chuck like that. And I've done some slight alterations to it. One of the things I found I needed to do was that little step inside. I had to increase the diameter of it, so make the shelf smaller, if you see what I mean. So only the metal rim of the tyre was sat on that, and not the any of the wheel centre, and that was to ensure it was properly concentric. I did in fact machine the inside of this down to ensure as best concentricity as I could, fully aware that I've kind of got compound errors insofar as I've got any runoff inherent in this collet plus any runoff inherent in this collet, but I've got to live with that. The wheel just pings in that, this goes in the collet, and it all tightens up, and actually it seems to hold it quite true, as long as you make sure that the wheel is pushed in firmly and you push this right back against the chuck as you tighten it up. And I then put a 2mm drill straight through in one pass. Now, I have found that the resin is quite understandably softer than the plastic the manufacturers use, and so the hole will enlarge more readily than proprietary plastics. So you kind of got one shot at it, hence taking very great care to make sure that it's nice and true first off. The first time I tried it, the wheel I think was bored nice and true. I then fitted the axle manually, and it wobbled a bit. I've had worse, but it wobbled a bit. I then tried a slightly different way of mounting the axle, and I held the wheel in this, mounted in the lathe, so the wheel was in this, in the lathe, holding it all nice and square. I then drilled it with a 2mm drill, so it was all nice and nice and true. And then I replaced the drill with a bit of axle material, and introduced the axle material into the bore nice and true by advancing the drill chuck, and that ensured that the axle was going in perfectly square to the wheel, and that seems to have done the trick. And that's exactly what this is. The axle was held in there and shoved in the wheel through that. Now, if I start this up while you have a look, that's the result I've got. There is no appreciable runoff. and maybe a teeny bit, but nothing I can see and worry about, and it's certainly going to run fine with that. You see a slight coloration wobble and all the rest. That's the centre changing, for want of a better description. The edge of the rim is pretty constant. So if you use these collet chucks and you fit the axle in a precision fashion, in the same way that you drilled it, i.e. machine fit the axle, then you would appear to get a nice accurate job. So that's well worthwhile. The short story is these printed chucks seem to work, and seem to work quite well, and I've certainly got away with making my own wheel centres and getting a decent result at the back end. So I'm well pleased with that. I'm in the process of printing a collet chuck for my cranks, which will hold the outside cranks in exactly the same way, and I can drill them accurately, and we'll see how that goes. So I thought that would be of interest to people. A good experiment that appears to work. Just so people can see, this is the FDM printer. It's a flash forge, and this is it printing the collet chuck. Now this one I'm printing with the chuck to the top, so I get a good finish on the chuck end. I think I should have done that before, and we'll see how that pays off. Right, that's the news. Cheers.